Hey folks, welcome to Chai Samosa. SamosaChai.net, by the way,
Samosa
sorry.
chai, yeah.
welcome. And
You
I'm
seem to
Vivek.
be lacking a chai.
Uh, yeah, it's basically either you have chai and samosa or samosa chai. It's all the
Mhm.
same for me now. Okay, so I'm Vivek, a senior cloud advocate, and I have Nish here with me. Hey Nish, how are you?
Hello. Very well. And in fact, I'm so sorry that I couldn't join you last time because my local internet guy decided to pull the plug on that day, just 10 minutes before the show. But I know it went really well. Thank you so much for, filling in and helping that out, Vivek. And I know that you have now transformed yourself into a .NET developer alongside your regular expertise on Kubernetes and things like that, right?
Yeah. Yeah. So, you know, uh, it's very difficult to run this show without a co-host because
Hmm.
this is a fun show, and it's basically if you don't have anybody on the other side. I was feeling very difficult. Okay, should I have crack a joke or should I not crack a joke, and and
Who's going
basically
to laugh at
run.
it?
It was in yeah, and also laughing alone. It's bad, as well.
Yeah.
That will be a really difficult one, so that's what it is. And by the way, since you missed last sessions, so I have a recap for you.
Fantastic. Let's go with it.
so, so what we have discussed in last two sessions basically is basically we went through what our microservices are, why microservice, and what is the advantage of microservice, and what are those technology and tools which are required to set up a cloud native microservice applications, right? So we did learn about Docker and Docker container. We learned about Docker Hub, and we also did building an app in local Kubernetes instance as well. And we did see a couple of use cases with respect to Kubernetes cluster, like scaling and resilience and other things, right? So we did run through all of these things only because we wanted to set up the next few sessions, which we are going to drive, which is very very deep dive into building microservice applications, right, Nish? So this
Mhm.
is just a base which we set it up, and if you have missed those episodes, and if you want to go back uh, and learn and do it yourself as well, I have launched a Cloud Skill Challenge, and this is the QR code. This is the link for you to go and run these learn modules on your own, and spend some time there and learn all these things which we did in last few episodes, and come back to our live episodes from today, right? From today, next few episodes of Samosa Chai will cover very deep dive discussions on microservices. So, what is your take
Uh,
on this, Nish?
Vivek, just a quick thing. I think I see someone from LinkedIn, Sujay. He mentioned that he doesn't see your screen on live stream, but I see it on YouTube. Like it seems to be fine. I see your screen, so I don't know if there's any way to fix that. Maybe you want to reshare again, like stop sharing and share again, maybe just to be.
Uh, sh- Share the screen, you mean to say?
I mean, whatever. I'm able to see it. I'm able to even verify that it's also seen on YouTube. But I this seems to be from the LinkedIn. So
That's an
so
interesting one.
yeah,
Let me reshare the screen. That will be good.
yeah. Let's do that. Let's stop sharing,
Yeah,
and if not, please come to the YouTube.
YouTube.
It's if you search for Microsoft Reactor on YouTube, you should be able to see the video which is live.
Nish, if
And
you can post the YouTube link in the chat, that will be helpful as well for
okay,
everyone. Yeah. So, yeah, I've reshared it. Hopefully, it's visible for everyone.
okay. Let's hope so. Um, yeah, I haven't checked the LinkedIn side of things. Okay. Yeah. Let us know if there's anything else. You can come to YouTube and just watch it if you're not able to see the stream because it's just going right from the StreamYard. Like from our side, it's going fine. It's probably at the end where it's not happening on the LinkedIn side. Probably it's working on YouTube. So if you want to come to YouTube, It's search for Microsoft slash space reactor, and you should be able to see this video live up there.
Yep.
Cool. Vivek, sorry to interrupt. Let's go on.
No worries. So I think this is the action for developers. I even shared last week. You were not there, but I did share about this Cloud Skill Challenge. I did launch this Cloud Skill Challenge, which is a combination of all the Learn modules which we are driving here. So if you're watching this and if you want to do it yourself later on, just go there and run through these Learn modules. So going to the next, I did share a bit of Kubernetes workshop as well in the last few sessions. It's basically if you're a first timer on Kubernetes and you want to learn Kubernetes deep dive. So this is an amazing workshop. You can uh, you can also spend some time here and learn Kubernetes in a very production oriented way as well, and you can
Wow,
see the diagram the way it has been
that
set up as well.
looks so amazing. I don't know what's in there, but it looks so amazing.
Yeah, it's also a microservice, by the way, and they're a rating
Nice.
app, so it's nice.
Oh,
So
okay. Yeah, I know about that. Yeah, that's pretty cool one. Yeah.
let's go, Nish, to today's objective. So what
Yeah.
are we learning today, Nish?
Yeah, so before that, there's a question from Jaydeep. Will this get recorded and will be available for reference in future? Yes, absolutely. I mean, as I mentioned, if you go to YouTube, Microsoft Space Reactor, you should be able to see this video running there as live. And if you basically come back to the same video again, you will see the same recording, same live stream being recorded. So if you're someone from the future, hi to you too. Uh, so this is going to be the same video there. Okay. All right, let's talk about what are the objectives. What are we going to learn today? We are definitely going to look at microservices in more like in a production scenario. Well, technically, it's something with an asterisk. Like it's we don't want to call it as production because there could be many ways you can implement things, but we just want to show you like how would you do something close to a real world scenario, right? So we will look at an existing microservices application, which is an e-commerce application. So you will see things like shopping, how you can purchase swags, digital swags, add to cart and complete the purchase. Absolutely no payments, but we mock those payment gateways and things like that. So you can see that existing infrastructure being set up, and there's no need for you to do Docker or Kubernetes with in terms of microservices, because microservices, we discussed this previously as well, they're just an architectural design pattern. But today, with the kind of cloud and the technologies that we have, these microservices can be developed quickly and pretty easily maintained using Dockers and Kubernetes, and they kind of like knock off all those 12-factor app scenarios that comes up, right? So so we show this using the cloud native technologies like Docker and Kubernetes. So you'll see us deploying and hosting it in a Kubernetes environment. And then the interesting thing that we're going to do is we're going to learn how to do it in a production or in a real world kind of scenario. Like if you were someone to come in for the first time and look at this architecture and say like, hey, I want to build a feature into this e-commerce app. So how would you go about doing it, right? So we'll identify the feature, what domain does it belong to, and then create that new feature. And then we'll implement that and deploy that into the existing infrastructure. So that's what we're going to look at it. It's going to be it's an intermediate session, but you just have to watch us do it, and we are happy to take your questions, answer as much as we can, and while we do that, we'll also cover like container registries like Docker Hub and Azure Container Registry, and we'll also talk about how do we deploy this new service that you're probably going to build and deploy them to the Kubernetes using Helm and things like that. So it's a pretty, I would say, a packed session. So we'll try to keep going as much as we can in terms of like answering your questions. But watch this show because you're gonna see us do it. We're gonna make Vivek write some .NET code without an editor live on the inside the browser. He's gonna save those files. He's gonna deploy them. So we're gonna watch. There's gonna be a lot of fun. Well, Vivek do it. He's gonna do it, right?
Yeah,
So
and I'll copy the code and
yeah.
the code.
So
Yeah.
yeah.
So let me introduce to the problem, by the way. So
Mhm.
so this is the eShop which we have, and you can see there is a bit of swags you can buy. You can buy a hoodie and other things, uh, in not in real, but it's just a mock we have. And there are a couple of services which is already built and deployed to Kubernetes. And today's session will focus on adding a new service, which is a small service, which is just to have a coupon code, just to, while you're buying something, when you're going into the checkout, you're applying for a coupon. So how do we add a new service, which is a coupon service, to the existing service, and how it all integrates and how it all works together? So that is what we are going to learn, Nish, today. And before we
Fantastic.
go there,
Hmm.
let's see the architecture
Yeah.
of the whole eShop, right? So what is architecture is all about?
Yeah, so I'm a .NET PM. I maintain the architectural reference guides and reference samples, and this is one of the samples that we maintain, which is called the eShop on containers. As the name says, it's all about learning to build a shop on the web using containers, right? So this is the current architecture that, as you look at it, we have different microservices. So you can see that there is a catalog microservice, there's an ordering microservice, there's a payment service, a basket service, a coupon service, and so many different microservices, right? They're all independent, as you see, and they all have its own databases. I mean, we have discussed this in the previous episodes, like talking about how do you kind of like separate databases to like identify your microservice, identify a business domain, and then make sure that they have separate databases. So this follows the same pattern. And so how do they communicate with each other? They communicate with each other either synchronously through the endpoints, which within the cluster it could be through the through the name of the services within the cluster, or you can also using integration events, like you can use the event bus or service buses for asynchronous communication. So so that's how this has been is been architected, and it also has an exposure to the client applications like the web client and even mobile clients for that matter. They can connect back to the services. Well, you can actually go ahead and expose endpoints for each of these microservices separately, but it wouldn't be wise to do that, because you can also follow the API gateway pattern, where you can actually restrict the ingress traffic at your at an endpoint like an API gateway, and then allow only internal traffics from there on, right? So you can use the various advantages to using things like API gateways is like you can use HTTPS termination or SSL termination, TLS termination, and things like that. So internal traffic can be on HTTP, and you will basically secure your network at the API gateway level. You can also use services like aggregators, which is like if you have multiple services, you do not want all the services to be called by the client. Instead, it calls the aggregator, and aggregator will make internal calls and collate the data. It can probably cache the data, and then it can respond back to your services, right? So various things out there. Um, so yeah. So
Yeah. So
mhm.
what I like about this architecture is how you can see this, right? So there is different microservices, and these are all decoupled. So if you missed couple of sessions we did, this is an example of how each of these microservices are decoupled, and it's not affecting the other services, and it has its
Mm,
own database, right? So that's
mm,
the amazing part of it, and it has both the way of communication, synchronous and asynchronous as well. So that's a nice way to set up your microservice applications as well, right?
right.
Let me go to the okay. So this is the main part of communication between two services. This is from a asynchronous communication, where the asynchronous means where communication can be paused, or it can start and stop those communications and other things, right? So that's it's not one-to-one live communication. So you can see here we are using RabbitMQ in this example, but you can use Azure Service Bus as well. And you can see here there is every microservice can create event, and it's basically a publish and subscribe pattern, right? So every microservice can create an event and publish that event, and share it on a queue through an exchange. And every service can subscribe to the specific messages, which is specific to its domain as well. So if you see, um, in our specific example as well, right? So uh, it's because coupon is a specific domain, or catalog service, or the basket service is a specific domain. If there is an interaction between two different services, there is exchange of messages through publish and subscribe. So that's how it's been set. So it's not directly interacting with each other. It's basically using message queue in between to interact with each other. And this is also for scale purpose. This is also to make sure that we handle the traffic, and there is a decoupling of all these services as well, interaction between these services as well. And also there are various ways to build this as well. There is fan out strategy. That means all the messages is sent to all the queues. Or there is a topic which is very popular, where you are specifying particular message going into which queue, and which specific microservice can pick it up, or who can subscribe to this topic. Whoever is subscribed to this topic can pick up the messages, right? So that's how RabbitMQ works. Basically, it's somebody is sending and somebody is receiving, and there is a in between post office kind of a thing, which is helping these messages to talk to these services to talk to each other via this exchange server. So that's about asynchronous interaction.
Yeah,
So when it
and
comes to
RabbitMQ is just used as an example. Like it could be anything. The important aspect is we use an asynchronous communication pattern when you want to communicate with microservices, especially like for example, if you're making an order placed and you want an email service to kick in and send an email, right, or a payment gateway to start working on the payments. You basically publish that event, and whoever is whichever service has to respond to that will actually subscribe to that event and then respond to that. And for the infrastructure, we're just using RabbitMQ in a container. But in reality, in more like a real world, you would probably use something like an Azure Service Bus or something like that, which gives you those guarantees of message deliveries and things like that, right? So,
yep. And when it comes to synchronous, so Nish, you want to
yeah,
explain how
yeah.
synchronous work?
Yeah, so API gateways. So, for example, whenever you have the mobile client or a web client, and it needs to connect back and query the data, it needs to connect back into the backend APIs. And if you look at these, each of it, like catalogs, ordering, payment, they all have endpoints. A synchronous endpoint, for example, it could be a REST endpoint, or it could be a gRPC endpoint for performance reasons, and you can expose that. But as I mentioned previously in our previous slides, where you don't have to expose all of them to the end world or the mobile clients or to the web clients, because they don't need to know those and all the services. They just need to know an endpoint where they can connect to. So that's where the API gateways come into picture, where you put a gateway in front, and that's the system, or that's the endpoint which is actually exposed to the client world where people can connect to. You can have multiple API gateways. For example, you may have third parties want to connect and query your pricing, maybe, or they want to maybe you have another third party endpoint where you want to work with ads, where you want to configure coupons and pricings for specifically for certain products and things like that. So you can have multiple API gateways too, but the important aspect is to kind of like segregate that access of internal services, to kind of like separate that from the external world. So we have API gateways, and part of the API gateway, one of the other patterns that we use there, which is the aggregator pattern, where we kind of like, for example, let's take an example of a mobile screen, where you have maybe a screen where you have to display user information. You may have to display their order transactions, previous like history of transactions. You may have to probably have show what is in the current basket. But then these are all different services behind the scenes. So you'll have to query multiple services from the mobile client. So you don't have to do that. Instead, what you can do is you can hit the API gateway internally. The aggregator can actually query all these things, whatever is needed for that screen, and then it can provide those data back to the user. And one of the interesting things people do in these aggregators is like they cache the data too sometimes, so that it is faster, so you don't have to keep querying multiple services. Instead, you can cache some of the things, like for example pricing, or something else, like for example user info or something, which can be cached. And so whichever is frequently accessed and not frequently changing can be cached, and then those can be returned back quickly, right? So yeah, a few things like that are super beneficial when you go with these patterns. And in this case, we are using the Nginx reverse proxy for kind of configuring internal routes, but also it's also configured as an ingress controller for external traffic from Kubernetes. But that's for simplicity reason. You can even can go beyond whatever you want to, right? Yeah.
Got it. I think if you have a mobile view, I think this aggregator will help you to even access through this, right?
Yeah.
Through the aggregator. Perfect. And by the
Yeah.
finish, there is one question which is very specific to this one, so that's why I want to take it. Uh, this is on the pattern, the aggregate and BFF pattern. Is it the same?
Yeah, you can call it. I think there are under BFF there are multiple things that comes, like gateway offloading, gateway routing, and all those things which comes under the BFF pattern. So basically backend for front end. Basically it's the backend implementation for your front end client. So yeah, there are multiple things that come in, but aggregation, I was specifically focusing on the aggregating multiple requests and providing a single response, right? So yeah. A great question, by the way.
So, should we just go and review uh, the code? And first up, I'll just show people this is the learn module which we are doing,
Right.
and this is the learn module. And I'll go to the next part, which is setting up the environment. So this is a magic script. All right. So
Yeah.
this is a magic script.
Yeah.
Go ahead,
So
Nish.
we I think shared this link, right? Did we share the link on where this module can be, or where people can give this a
Yes,
try?
yes. It's there in my it's there in the cloud scale challenge. So the
Okay.
link which we shared at the first. And
Great.
and by the way, how you can get this up is just go here, go to the cloud shell, click on the cloud shell. So for example, if I'm here, just quit it and just click on this icon here, and you get the cloud shell enabled here. So that's it. So you just have to run this magic script in the cloud shell in the Azure portal. And once you run this script, what happens? So you have the complete eShop running for you, and it is deployed onto Kubernetes service, and it also has container registry, which is the repository for container images, and everything is set, right? So even the uh, Kubernetes and connection is displayed. So basically, let's go back here and show what it is going to display as. Basically, this one, right, Nish?
Yeah. So just to give an explanation of this. When we were building this module, one of the things that we thought through is like, okay, how can we make it easier for people to get quickly to something and then start learning? So one thing we eliminated totally is to the need of having a developer box. Like you don't have to come install with a Kubernetes, or you don't have to install Visual Studio or anything. You just have to go into this, sign up for an Azure subscription if you don't have one. That you can start off with a free trial, and we the script, that magic script that Vivek is talking about, what it does behind the scenes, it's actually goes and spins up everything that is required, and it just goes and installs the C# and container. So if you're running this yourself, please note that sometimes it can take too long to set up. So it can take anytime between 10 to 35 minutes, 40 minutes. It has happened. Sometimes Azure is busy. So if that happens, there's nothing to worry about. Just wait until whatever screen that you're seeing right now, it needs to reach till that point, right? So once it creates successfully, it is going to create a public IP, and then it's going to expose this, and it's going to deploy all your services into your Kubernetes. So if you want to, Vivek, if you want to do a kubectl get pods or something on your Azure CLI, we can show them how this is using the Kubernetes there, right? So there you go.
Yep.
So yeah, so it has, if you see, there are 3 links that has come as well: centralized logging, application status, web spa. So you see this, these are all the pods that are running. So these are all the services that are running behind the scenes. There's data, there's RabbitMQ, and all those things. They're all running inside the container. Vivek, one more thing if you can do is open the web status URL, which is the /web status. Yeah, there you go. So if you look at this one, so this is the health check. We're going to implement a health check in this module too. So if you do a web status, you should see that all these services should be green, because this is how we actually let the services know that everything is working fine and we are healthy. So wait for these things to turn green, and then you can hit the web spa endpoint and see the eShop and containers application yourself, right? So so Vivek, so what are you ordering for me today?
What do you want?
Let's get some t-shirts and hoodies, and yeah.
Yep. Let me log in and buy you some stuff. Right. The password. There you go. So I would like to gift you pin
So yeah, for sure.
and a hoodie,
Mhm.
a cup as well. We
Yeah,
can have all 3.
I accept all gifts. Yes. so you can say that, you can go ahead and check out. That's
Check out,
and
and you can see there is no coupon service here, right? That is
yeah,
such something which you should keep in mind when we design a coupon service here. But then I'll place the order, Nish. What
sure. Yeah,
happens after I place the order?
you need to provide your credit card details and make a payment. No, we don't do that. So this is this is an automatic process. So behind the scenes, what it is doing is it's actually making a placement of order, and then there is a mock services that is coming in and completing the payments, and it kind of like getting through the entire process that is needed to make an e-commerce transaction possible, right? So you'll see this as submitted. After some time, you'll see this order accepted, or validated, or waiting stock validation. So now, during this status, it's basically looking at catalog to confirm that there is stock and it can be shipped. So behind the scenes, these are all things happening, and there are a lot of asynchronous communication happening. And at the end of it, it becomes paid, or like once the payment is completed, we'll just call it as paid, right? So and you can also see that automatically, if you're on the screen, the events are coming in. It is updating these events, and this is all happening through the Signal technology. And there you go. So I think that should be done. So order ID 1, we just made the payment, and the only thing that this does not do is we don't ship anything from the site. So it's just a demo one, and so this is what we have already. So this is what, when you do that magic script, like when you copy and paste that thing, this is what it's going to set up for you in the Kubernetes cluster. Now what we're going to do, so what are we going to do, Vivek?
So we have this up and running. So we have reviewed the solution already.
Yeah.
So we will go and review the code. Before we review the code, you want to discuss about how this is. Okay, this is the what we did now.
Yeah,
So
this is something which we
yep. So let me go back to the slide.
Mhm.
couple of things, right? So from a design perspective, what we are going to do for a coupon service, right? So what is that? What we are doing today is we're going to add the coupon service now. You saw the demo. There was no coupon service there. We are going to add it. So these are the four things we are going to do. We're going to design a service using domain-driven design pattern, and we're going to containerize it and publish the image to the Azure Container Registry, and then we will redeploy the code to Kubernetes cluster and uh, see how services get can talk to each other, how order service is redeployed, but the new coupon service will be deployed for the first time, so these two can talk to each other and perform some actions. So this is what we're going to learn, and we're going to do live right now. So from a business requirement, Nish, what are those
Mm.
things which we are going to do?
Yeah, I think this is a fairly simple coupon management here. What we're trying to see is we're not validating like which catalog item we should apply discounts to and things like that. We're just saying, okay, we will have some discount codes like it should start with DISC hyphen, it can be 5, 10, 15, 30, some basically as unsigned integer. And we will apply that as dollars when we make that transaction, right? So if you applied disc hyphen 5, there's a $5 that is being applied. This, if you apply 10, it becomes 10. So if you buy something at $30 and then you apply a discount of 30, it's going to negate all of it and you're going to sell it at zero price. But I mean, well, that it's just a simple thing. So we just want to keep it simple. The other few things that which we thought about it, like how do we show how other services are working with each other. So in this case, one of the requirements we kept is like the coupon service must validate that the coupon code is available before following it. So we'll have a text box, and then where when the user is applying discount code and say apply, it's going to query the coupon service and say, is this coupon valid? Is it available for it to? Because sometimes the coupon would have been used, right? By the time someone applied it, you go in, the order would have processed it. If the once the order is processed, that's when the discount coupon becomes invalid, right? Until that order is completed, it is going to be still showing as it's valid. So it's kind of like a first first come first serve basis. So and yeah, it's a very simple thing, because when you're sitting to learn, you don't want to think about complicated business processes. We just want to understand, okay, this is the business process. What is the approach that we're going to do to implement this, right? And upon the validation, so the way it works is like, once the validation is done, it basically so for example, when an order service is order placement starts. So once the coupon is available, once it shows in the screen it's available, it'll start the processing. But order will not processing will not get completed, because at the time of order processing, there will be another event raised to ask the coupon service will be asked to validate this again, because it could have been used between that transaction too. So only if the coupon service says, okay, this is an okay order, it will order processing system will go ahead and process it. If it was used by then, it will just fail and say, like, maybe it'll tell the user, this order is we can't process it, or it could be a completely a business requirement that you can say, okay, it's not the user's mistake, but we will take that on us and we'll process that, right? So those are kind of business decisions, but this is how we're going to implement it, like asynchronous style, where when the validation starts, you basically ask the coupon service to validate this, and once the coupon says okay or failed, depending on that, the order will again kick in and do the rest of the things, right? So the other thing that we also do is when the order is canceled, for any reasons we cancel the order, we also have to release the coupon from its state of used to non-used. So that also is another set of code that we need to write. So this is like a fairly simple business requirement, but it touches on a few things where how these services work with each other, and that's what we focused on. We did not focus on how do we implement this coupon service right. We focused on how do we create a microservice where a student gets to learn how these services can work with each other. So that's all we thought about, and that is how we have kept this business requirement simple, right? Okay, so
Yeah.
up next, yeah.
It's a domain driven design pattern.
Mhm.
So it's built on this. So we are building this coupon service on a specific pattern. So what does it mean is the domain is nothing but a business. It is equal to business, right? So in a domain design pattern, what you're building is everything is specific to a business problem it is solving. Say for example, the catalog service, it is focused on catalog service, and order system is focused on order service, right? Order system, it is to manage. And specifically, if you see today's example, the coupon service is focusing on only solving the coupon related problem, that is to validate the coupon or to reject the coupon, and also make sure it takes care of whether the coupon is been applied already or not. So all these things, whatever is concerning to coupon, is taken care by the service, but it is not responsible for making sure that order is valid or not, because the order system, order service is the owner of that. So that's how that's how the boundaries has been built, and that's the main reason for using the specific design pattern from a domain perspective. And you are creating a boundary. Coupon service is focusing on its own business problem, and order service is focusing on its own business problem, and both of them are interacting with each other and relying on each other for making sure there is a seamless application built from a user perspective. From a user perspective, there is no differentiation there, but you can see there is an interaction happening to validation and other things between these two services, right? So that's the basic of using the DDD pattern there, Nish. So let me
Yeah.
go into the next
So
few
just to be
steps.
clear, domain-driven design is a very vast topic, and there are many things that
Yeah.
come in this. But we just want to the coupon service we have used just the CRUD operations here, but we do use something like integration events and things like that to make sure that we follow those DDD approaches. So yeah, so remember that that's there are many ways to do it, but DDD is the most popular way to kind of like segregate that under identifying the business context and then building things. So here we have identified as coupon, and that's the feature that we're going to build. That's going to be a separate service, separate microservice, and then we're going to see how we're going to integrate with each other, right? So
Yep. So quickly run through the
yeah,
technology stack.
yeah. So when it comes to microservices, the tech stack, it doesn't matter, like, because you can work with any technology stack. uh, Between the microservices, they do not know the implementation details, so you can have one service on .NET, the other service on Node.js and Java and so on, right? But in this case, for coupon service, we just took a decision that, okay, let's build it on ASP.NET Core Web API, because it's really fast in terms of responses for web requests and things like that. And we're using MongoDB. We chose to use NoSQL for storing the coupons, and then we also use containers. So because rest of the microservices uses containers, we can use the same infrastructure within Kubernetes. So we also took the choice of containerizing it and deploying it. So that's the decision choice. And the important aspect of microservices, like, each business can decide its own technology stack. That means each microservice, like catalog, can be completely different. For example, basket, right? It has its own database, which is Redis cache. Rest of the databases are SQL servers. And again, it's not the same SQL database. It's completely different. You can implement anywhere. So that choice is, in this case, for database, we use MongoDB. Cool.
Yes. So let me share the learn module
Hmm.
in the chat, because there are people who are asking how we can download this PPT.
Hmm.
So this you can this PPT is built on the learn module which we are discussing. So you can just access this learn module through those uh, the cloud skill challenge which I have shared. Okay, let me go back to the slides, Nish.
Hmm.
How does this all integrate? So how does it work in from a execution perspective? So it's very simple. The order service, it basically creates an event, and it creates an event. it's basically an awaiting for coupon validation, and puts that message on the event bus. And coupon service on the other side picks up this message and invokes the appropriate methods to interact with the order service, right? So basically it is getting information from the event bus, and it is invoking a method to determine what needs to be done next, right? So that is the first part of the thing. So second part of the thing, what it does, Nish. So what is the second phase of it?
Yeah, I think the next thing is like, once coupon is valid, the coupon service will mark that coupon as consumed, and then it raises another event. It's not calling the order back, but instead it is like only raising an event, which is the order coupon confirmed integration event. I mean, you can just see how even these names are more business driven, and that's why you see that length. So you're just saying order coupon confirmed, and the order will kind of like take from there on, because it is listening to this event to process further, right? And in case something has gone wrong, again, what coupon does is it just makes a coupon or a coupon rejected integration event, and based on that, again, the services will kick in, and then it'll do its thing. So you can see how it is very much disconnected from the other service. All that coupon service knows to do is take on that event, check if it's consumed or not, and then or if it's consumed, then you say it's rejected. If it's not consumed, you say it's confirmed, and then you just raise an event. So that's the simplest thing that microservice is doing, right?
Yep. Let me
So
go. Let's go it and implement.
yeah, let's go and implement the service. So that's going to be
Yeah,
fun,
we're
Vivek.
yeah, it's going to be fun because we are going to do a lot of coding. Yeah. And the first up, I'm just copying this and go to service coupon. So service coupon.api, right?
Yep,
So let me copy the code, Nish, for you to explain later.
sure.
So let
Yeah.
me go into
So
the source service
mm,
coupon API. Oh, I forgot where we're going. Coupon API. Oh, okay, controller. Right. See, I'm good at .NET.
yeah, so you just make sure that you're reading the instructions correctly. Copying is the easiest thing, but pasting where to the right place is the most important aspect to make sure the code runs well. So yeah, so this is
That's
the coupon
correct.
controller. Yeah, so this is nothing but the REST endpoint where the request will be made. So we're just creating a new endpoint which is called the get coupon code by async, and all that it is doing is it's exposing a get method, and then when you query that, it is going to look at the repository, which is in this case MongoDB. So we have these things baked in already so that you spend less time kind of like writing the entire thing, instead focus on few important things. So what it does is basically it's going to check on the coupon and say if it's available or not. So that's the simplest thing, and that's what you're going to do it in the controller. So if you're using minimal APIs of .NET, you could just also do that in the minimal API. You can expose and endpoint that way too. And the next thing that you're going to do is you also add a health check configuration. Remember, when we started off, we also showed the web status dashboard where all the health check it was querying for, and it was showing. So we're going to implement a health check in .NET. So it's very easy to do it by using the iHealth check implementation. So in this case, what we did is we have Vivek, can you just go into that method which is add custom health check? So you can find that method in the services extensions, I think. So if
Here.
you look at
Or
the yeah, come down.
oh, I've already done that. I've added the custom health check configuration at the
Mm.
startup script.
Yeah, I'm
Startup
saying save
CSV.
save this file. Don't forget to save this file. By the way, this is
I've
an
saved it.
online editor within Azure CLI, so it doesn't have IntelliSense. So make your semicolons and other things correct. Otherwise, until you do a .NET build, you will not know where you're making the mistake. Okay, so now the other one more thing I wanted to show is whatever this add custom health check is there, right? So let's go ahead and look at that one. If you go into, okay, let me tell you where exactly
Y-
that
You
one is.
want
I
me
think
to
it's in
go
the
to the
service
health check?
on the left. Can you go up a little bit? No. Just go to the code. I just want to show the code. Go to the
Oh, actually,
extensions.
you want to code.
Yeah,
You
open
want
the
me to go
coupon.
to the
Open the
coupon
coupon API.
service
Yeah. So this
and
is the new
extensions.
service that we've. Yeah, iService
This one,
conditions. Correct.
correct.
So if you go inside this, you will have add custom health check. Right. This is where we are writing the extension method. So we wanted to show how you're using health checks.
Uh, yeah,
Yeah, there you
this
go.
one.
So this is so this method is already there. What Vivek just now did is basically adding that into the stream, right? So what it is doing right now is basically we are adding some health checks. If you just look at services.add health checks, and we're adding a self health check, and you see that dot add MongoDB. So that's the extension method. So you actually .NET gives you a health check implementation, and you can go and implement your own health checks for each service. Because, for example, your service coupon service depends on a MongoDB, and you can write an implementation for iHealth check saying, okay, how do I connect to the MongoDB and say that, okay, my service depends on this database, and that database is healthy, right? So you will write some code on connecting to Mongo, and take the connection string, connect to Mongo, and say, okay, that's healthy, and you report back healthy. So we use I think it's been at core health checks library. I don't remember the exact name of it. We can look at that in a bit.
Oh,
So we're using that.
yes, this one. Health check library, right? Custom health check extension. This
No,
one.
that's extension method. So it can go down a little bit. Go down. Yeah, there you go. ASP.NET Core health
This one.
checks. Yeah, so we're using those extension, NuGet package, and that will give you the extension method called add MongoDB. So that has those implementations already. So if you look at ASP.NET Core diagnostics dot health checks, that's those are the NuGet packages that you can use, which has these checks already baked in. There's checks for SQL Server, there's check for Redis, there's check for like hundreds of dozens of things. And you can also write your own if you want to using iHealth check. So it's already written. So what we're going to give it is a tag, and then maybe the connection string or something like that. And the next thing that you need to do is now you need to expose endpoints where these health monitoring systems, like in this case we are using web status, to query your coupon service and find out whether you're healthy or not, right? So that's what you're going to do next. So Vivek, you need to add that thing to the controllers again. So if you go to the
This
configure
one, right?
method, correct, yeah,
This one in the extension, right? Extension.
yeah.
This is for map controller and config.
Mhm.
Okay.
Yeah.
So here in this file only, no?
No. Go to the startup.cs.
Oh, sorry, I missed that. Yep,
Yeah.
that's in the
Go to
startup file.
configure method. So
Configure
yeah,
method. Yeah, this
come
one.
down, come down. So right below
Here.
the there you go. Yeah. So right there. So okay. So why are we talking about health checks here? Because we built a coupon service. We already have a lot of things baked in for you, but we want to show you how to write health checks in .NET. So what we're doing is we're creating endpoints, which is /headc, and we're also having an endpoint called Liveness. So your coupon service will expose these endpoints, which the other systems can query to know what's your health status. So when this query is made, it is going to connect. So for example, if there's a MongoDB, it is also going to connect to the MongoDB. It's going to execute that health check and find out what is the status of it. Then it'll report back saying is it healthy or not healthy. So you have two endpoints. You can see headc and liveness. So there are two. Why do we have these two endpoints? For two reasons. There's another reason, which is the liveness and readiness probe that we can configure in Kubernetes too. So that is the reasons why we have two endpoints. You can go ahead and explain liveness and readiness, and then I can go back and talk about how that is implemented
Yeah.
in .NET.
Yeah. So basically, when it comes to readiness, when you are spinning up a container, whether it's your container is ready to accept traffic, so that when it is ready, then only Kubernetes enables it. So that is where the endpoint. I will talk about a little bit of that when we talk about the YAML, how exactly it is picking up from the endpoint /headc, where you can see whether the container is ready to accept traffic, which is specifically from a pod, and then only the service is enabled. And liveness is if a specific pod is failing, it is not responding and it has some issues, you need to restart that specific pod, that's when you're going to do the liveness check. So these are two different things. Readiness is when you spin up for the first time, or whether this is ready for accepting traffic or not. That's when you're going to use readiness. And for liveness, it's more about making sure it is running and it is all fine, and you're going to periodically check whether it is failing or not. And then if it is failing, then you're restarting the pods there. So to do that, you're going to configure that in Kubernetes as well. But this, we are also using these things to make sure the we set up the health check as well. So it's not
Yeah. So if
like
you go
we're
back to
going
the
to use.
code quickly,
Yeah,
yeah.
let me
So
go there.
just do a
Yep.
quick explanation on that. Like, go to the code, like where you pasted this thing.
Yeah,
Yeah. So here
this
you
one.
go. So if you look at that, yeah, the health check, basically HC endpoint is going to query for everything and make sure that everything is healthy, because this endpoint is all about Kubernetes will not send traffic to this if everything does not stay true, right? That's all about this health check. But if your liveness is not about that, if your liveness says unhealthy, then Kubernetes is going to immediately kill that thing and then restart it, because thinking you are stuck, right? And that's why the liveness endpoints have to be pretty quick. So what we're doing here is we're actually going and checking for that self check, which is basically nothing but going to return back HTTP status 200. So every time Kubernetes, it queries periodically to your in a pod and check what is the liveness of it, and you need to be very quick in responding to that, right? And HC is point where you can go and check all the dependencies when they are up. Only then the Kubernetes will drive traffic to your. So this can be, sometimes your pods will take time to start up because it has to depend on various other services, and they all have to start up. So that's when you configure that way. So we just want to show you how you can do that in .NET. So you go and implement health checks, and there are some really nice NuGet libraries that you can use, and then you can provide your own custom as well. Yeah. Cool. So what is this? What is this file that we are looking at, Vivek? What what
So
what is this blue and red thing?
yeah, this is basically a YAML file, and this is the configuration file. In Kubernetes, we did discuss about it last time as well. Kubernetes is it's basically a declarative tool, right? So you declare what you want, and Kubernetes picks it up and make sure it set it up in that way. So that's the goal of Kubernetes, and this is the configuration you provide. And uh, just to set up the coupon service, we have we are working as a, it's basically a deployment kind, right? So on deployment, we have certain things: the metadata, the spec, and the template, and specifically the image here, which we
Mhm.
are providing, the image which we are going to build, which we are going to store it in the Azure Container Registry, where all the images are there. It's kind of a repository there. So you are
Yeah.
accessing that image through this YAML file, and you're building a couple of things. So we did talk about liveness probe, and there is a question as well in the chat that what is the time period it checks
Yeah.
for all these things. You can set it up here. This is where you can do the configuration as well, and this is couple of config map and other things which we have to provide there. So this is already there, right, Nish, in the deployment?
Yeah, it's all there.
uh,
Maybe you want to do a .NET build quickly, because these are
yeah,
things going to take time. So
let us go build
uh,
it and then show them this.
yeah,
Yeah,
let's make sure if Vivek is a great programmer or just a good programmer, depending on whether he has
saved the
pasted the
file or not.
yeah, I mean pasted the code in the right places, right? So yeah,
Yeah.
saving the file is an important aspect as well. Yeah,
And I've taken care of the semicolon, by the way.
very fantastic.
So where is the service? Okay, that service is yet to come, right? So it's not there
You mean the
after running this
catalog,
build. The
the coupon?
coupon, it's
It
not
should be
there
there.
yet. Yeah.
Okay.
No, I think we need to
So
run the
yeah, we need
script.
to do an yeah.
We need to run
So
the script
that's
after the build. We can see
mm,
this YAML file automatically being created. When you run the script, this specific script, uh, the YAML file, the HTML, which is required for the code. Everything is automatically updated in right set of places, and also Helm charts gets created for coupon service. And you can see, within the Helm, you have, at least four different YAML files are there, right? So one is for the deployment, other is for the service, and other is for config map, which is for maintain the configurations. And that's the main reason why we are using Helm here, because each service has minimum of four YAMLs, and you don't want to manage individual YAMLs, right? So you want to package it. So that is the reason why we are using Helm here. We are creating for each service, there is a chart .yaml file has been created. Whenever you run these charts, automatically the YAML files under the templates is picked and gets deployed with the
Yeah,
Kubernetes. So
you
that
may
is the
want to
main
go
reason
check
why we're
back.
using it. Now we'll see this. Oh yeah,
Yeah,
um,
great. Can you run
good.
the implementation script and then run it on ACR too, so that I think we
Yes,
can. I
I'll
can go ahead and
just
explain
do
what
that.
exactly this thing is happening. Yeah, so
Let's
that's going to
do
be quick.
an implementation. Oh,
Yeah, it's going to tell you what exactly it's doing. Basically, to save time, there are other services that is depending on like coupon. For example, like your UI has to know that coupon exists. So we have this code baked in a kind of like like an uncommented state or commented state, and we're just going in and commenting that to make sure those things are enabled. And we also have to let the endpoints as well know that the coupon exists, and we also have to configure the web status application that we have built to know that, okay, we also have another service, so we need to monitor that service too, and that's the HC and the liveness endpoint that we created that needs to be configured too. So this is what it's doing behind the scenes. So Vivek, I think you can do one more step, which is the ACR one,
yep.
which is, so that's going to take a little bit of time, because, and then you're going to come back and
This
explain
is a
about this.
simple structure which we talked about, right? So all
Uh,
we have to do is to create the image, keep, push that image to Azure Container Registry, and we have already set the YAML from where to pick it, and Kubernetes, Azure Kubernetes service picks it when it is deploying.
yeah,
So let us first
do this
push
stuff,
it.
yeah, because that's going to take a
It's going
bit.
to take time.
Yeah.
Yes, let's
So
do
we're
that.
using, yeah, ACR to build the image. When you deploy this for the first time, the entire installation is happening from the Docker Hub. So we have all these images to ready to get you started in the Docker Hub. So it's all happening behind the scenes. But when you are changing some things, there are few services that you change. For example, the web status application change. You added a new coupon service. That means new Helm charts are there. And then there is, we also uncommented a few things in the web spa application. So that also needs to be. So only those changes that you've done, only those microservices are basically built within the Azure Container Registry, and then we will go ahead and modify the Helm chart to kind of like take it from that registry. It's your new registry instead of from the Docker Hub. So you can see how using this kind of cloud native technologies is helping us. Just in the YAML, you can say, okay, I want to pick this image from Docker Hub. I want to pick this image from ACR. You can actually configure it, and Helm with its templating structure, it's furthermore configurable. Like you can choose between different container registries too.
Yep. I
Um,
think it's still
so
taking
there's another
time.
question. Currently, you're doing everything manually, but how to do this in CI/CD pipeline? I think that's a very good question. So we have a module on GitHub Actions as part of this entire curriculum. So if you want to check that out, go ahead and check that out. Because see, I mean, if you look at this code, ideally in a microservice world, the CI/CD pipeline for each service is also different. Even the repository for each service is going to be different. How sometimes you may be deploying to Kubernetes, sometimes you may be deploying just to Azure Functions or something like that, and it could be a microservice that way too. So the entire CI/CD pipelines, even the teams are different, so they all exist differently. But we're doing this to have all a single mono repo just to make it easier for learning purposes, because now we have to change the web status, we have to change a few things to kind of like uh, to kind of like make all the coupon feature available, because that feature, even though it's a microservice, those feature has to work with other services. So you have to change orders to send a new integration event so that coupon will pick up and things like that. In real world, they're implemented by different teams. They'll have a different release cadence. They may have two different services running together as well, a 1.0 and 1.1. So the new request may come through 1.1, and then it'll route through the 1.1 scenarios as well, right? But in our case, we're just keeping it simple for this module. So if you are excited about the CI/CD pipelines, go ahead and check that out. Check that module out. We explain that entirely. Yeah, and give that a try.
Yeah, I've just posted the link uh, for the Cloud Skill Challenge as well, where you can find that module as well.
That's a fairly simple URL, right? aka.ms/ you just write everything in small, samosa, chai, and dotnet, which is .net. So very straightforward. So yeah, it's an entire module that I can try, and so we definitely would be covering that in one of those for samosa chai sessions, but it's going to take a while until we reach that one. So you don't have to wait for us. You can go ahead and give that a try for yourself. And another tip is that we will be covering a lot of things within these sessions. So if you pay attention to it, you can go ahead and answer some of those questions within that module and complete that module pretty quickly. And yeah, so make sure that you are listening to us, and then go ahead and answer those questions so that you can complete that module. Okay, so it's going to take, I think, okay, we have hit the web spa version. So I think it's going to be another 4 minutes. So yeah, if you have any other questions, please feel free to post to us. We're just hanging out and having a good chat. So feel free to ask your questions. We can take most of your questions in. So what else, Vivek? Is there anything that we did not touch upon when it comes to Kubernetes?
Oh, nothing. I think specifically this one as well. So this is where we'll see it for the next few sessions as well.
Yeah,
so,
this is SAG, which is a logging monitoring
so
system.
next up is just we deploy this to Kubernetes, right? So
yeah, basically we update these Helm charts, and I think the only changes that is happening in these scripts are we need to kind of open the API gateway to know the new URL that we have, which is the coupon, and then obviously installing the coupon itself, right? And yeah, updating the web spa images, because now they are going to be pulled from the ACR instead of the Docker Hub.
Yep. So it should complete in a while. If you have any questions, keep posting it. We are happy to answer. We can take some of the questions as well.
So what are the things that we're covering next, Vivek? What's the next session?
Next session is about resiliency. It's basically how we can make sure that there is a seamless way of managing your application. If there is a lot of request which is coming in and the other service is not responding, how do you handle those kind of scenarios, either via code or via the infrastructure? Right. So basically, this is done. By the way, I'll just run the deploy to Kubernetes script as well while we wait for that as other
Yeah, you
things.
can
So
see that
it's
Helm
nothing but
uninstall.
yeah, it's uninstalling the eShop and reinstalls it. So there is a question basically, as it's a big
Okay,
question, so I can't read.
let me pull.
I pulled it.
Yeah. So as we are implementing health check, so in this, if you want to implement something like create pod only when request is triggered. So Nimavat, you have to rephrase that question for us, because, for example, your application can scale to 0 instances when there's no. Yeah. Okay. You're talking about event-driven It's more like a KEDA, Kubernetes event driven. What's that thing called? Event driven.
It's
What's KEDA?
Keda is
Mm.
Kubernetes event driven
Even auto scaling. Event
auto
driven auto scaling
scaling.
also.
Auto scaling.
Yeah. So yeah, I mean, you can check out Azure Container Apps for that matter. Like you can also scale set rules. You can set, okay, if there, I don't not have this much of traffic, then I can scale these things to 0, or I can scale it up to certain amount. So you can use KEDA to kind of like configure these things too, right? And Azure Container Apps actually does it very nicely. So check that out. Um,
So, Nish, by the way, we were able to deploy
oh,
to
fantastic!
Kubernetes, and you can see that there are a couple of health
Health
checks
checks, which is not.
which is
Yeah.
failing, and it will take some time refresh.
Can
It
you
is
open that
waiting for.
thing? Can you open the web shopping aggregator?
Oh yeah, I can. Yeah.
Yeah. So these are the two endpoints, unhealthy, which means it's going to take time to come up. So if you do a kubectl, it'll get pods. Also, you'll know that where we stand. And you can see that the refreshing status is at 10 seconds. So if you earlier someone asked about how can you configure that, you can if you're using a monitoring dashboards, you can also configure in that dashboard, because what individual health check implementation that it does is basically when that query is made, it's going to respond to it. So how soon or how fast you want to query is up to the monitoring system. So in
and
Vivek
we
showed how to do that in Kubernetes. Yeah.
and by the way, we will have a specific session on monitoring, um,
Yeah.
where we are going to discuss about Prometheus, how to integrate with Prometheus, and how to integrate with Azure Container Monitoring Service, Azure Monitor for Container Service. Sorry, how you can
Right.
use that to build this dashboard, and also we're going to discuss about these two things, which is second the uh, CQ, right, which we are
Mm.
using
Yeah.
CQs.
Yeah. Yeah. So there's another question: can we integrate external health check? Yes, absolutely. So the endpoints that we are creating is for that. Like once you create it and once you know how to implement health checks, then I think it's just very straightforward for other endpoints to know. You just have to let those endpoints know. So yeah, we will get into that session um, where we talk about instrumentation or code instrumentation and logging, right?
Yeah.
Where that's also one of the things about health monitoring too. Yeah, you can do that, absolutely.
So coupon service
So
is up,
cool.
and we're just
So
waiting for this one.
you can actually make the refresh things from 10 seconds to 1 second, so you can immediately know. Yeah,
Yeah,
click
I
change
forgot to
after that.
change this one.
Yeah, so it should automatically tell you when it is healthy. And
Yes,
yeah, there you go.
we're up.
Fantastic. So now if
So
you
we will.
refresh,
I'll go to the website itself.
okay.
Right.
Mm-hmm.
So again, Nish, I will
Mm-hmm.
buy you a hoodie.
Okay.
I like hoodies somehow. So and different mug for you, different mug,
Yeah, absolutely.
and even this hoodie is nice. I mean,
Yeah,
this is nice. You like black? Okay, take it.
I like
Okay,
all colors as long as it's written
all
.NET
colors.
in it.
Let me go and check it. Check out this, and you see the coupon. So what is that?
Yeah,
Something which I need to give here, Nish?
disk 5 maybe. Like wait,
Why?
$48, but disk 30. Let's use the maximum discount and
Maximum
apply.
discount for this. When it comes to us, I want to get maximum discount. Yeah.
Yeah.
So
So there you go. It's got applied. So when you
and
when
we
you
can
click
test
that
it.
apply, that's when the coupon in a controller where we added that method is going to be called, and it is going to validate. And now when you do the place order, that's when the internal implementations of coupon is going to kick in. So you can go ahead, and we haven't covered those aspects, but you can go ahead and check that coupon code to understand how this is done. But we just wanted to show you, as a newcomer, if you're coming into microservices world, how do you create a new service, think about health checks, and deploy them to the existing cluster, right? So
Yes.
yeah, you can go ahead and place order maybe.
Let me place order.
And there you go. So that's submitted. and next time if you come in and apply disk -30, it will say it is consumed once the order validation is passed, right? So you can see those events changing as well.
Here and here.
Correct. Yeah. um, yeah, you don't want to do all these things in your live real world scenario. It's just to show you how this is being done behind the scenes. So you can see that there's a new event there
Uh,
awaiting coupon validation, and then coupon service kicked in. It validated it.
it validated it. It's all fine.
It's all, yeah. Now I think it's just sun's paid. So once that is validated, then since in validated state, you now when you apply disk -30, it's not going to be allowed because it says
So let me go
coupon is
and
consumed.
continue shopping and test that
Yeah.
out as well.
Okay.
So this time I'll buy you white t-shirt.
I think we should definitely hire you as a tester because you're very determined on this thing.
This 30?
Yeah.
Huh?
Yeah. Click apply.
Oh,
Yay.
all working fine.
Yeah.
Cool. I think
So
this is how you can implement a new service and add to the existing service, and you're still not breaking any of the service, right? The If you remember when I came back to this eShop, it still remembered me, and I was not logged out or anything. I redeployed. I was still there, and if I had put something in the basket service, it would have been there itself. So test all those things, scenarios. Try and see how how you can break this, and let us know if you can break it,
we
and
can, yeah.
and probably we will fix that later on. Anyways, that's a joke. Okay, don't break it. Cool. Okay.
Send us a PR. We're
Let
happy
me
to accept that.
yeah. So let me go back to the uh, we don't want to do this. You want to do
Yeah.
this, Nick?
No, let's go back to the no. Let's. I think we crossed the time. So, um,
So let's summarize what we did.
so we talked about understanding the existing cluster. We did that. We implemented a new coupon service. We containerized it. So we did a .NET build, even though .NET build was much more like a local thing, but actually because when it goes to the ACR build, it is going to do a Docker build. So that's when it is containerizing, it is creating into a Docker image, and then we push it to the ACR. There are like so much of magic hidden behind the scripts, and we want you to just go and explore those scripts because it has some really gold standards on automation and things like that. So feel free to try them out. And as you said, we did this entirely without a dev machine. You could totally do this on an iPad in a browser, right? You can execute these modules completely on that, right? We deployed also the Docker container to AKS cluster, which went great. And I'm so happy that Vivek is kind of like, he's getting better at .NET. He's copied the thing correctly. He has pasted in the right places. He saved the file. He used the right commands to compile it. I'm so happy that Vivek is making success.
You're converting me to a .NET developer. Yeah, correct.
I'm making you a
Yeah,
cloud native developer
yeah.
with with fast
With
performance
.NET.
.NET.
Perfect. So I think I mean I just want to call out action for developers. I've given 78 days for this challenge. Is only reason because there are a couple of learn modules which takes 1 hour, and there is a lot of concepts we are covering in these learn modules, and each time I go back and read these learn modules, I'm learning something really new. And I would urge all developers who are watching this, just go to this cloud skill challenge, and spend some time, execute couple of these learn modules, start with the first few modules, so that you understand the concepts, and then go deep dive into the advanced levels, which will give you a complete understanding of microservices, right? So that's something which I just wanted to call out, and link is there in the stream as well. You can pick that up. It's easy to remember. It's just aka.ms/samosachai.net. And next up, okay, this is something which I had shared earlier as well. So you can also go back and learn Kubernetes. And this is
Our next session.
next up, next session, and don't miss this. So it's easy to remember as well. It's SC, which is samosachai.net. It is, and QR
Okay.
code is here. And by the way, that's a GitHub repo. It's not a it's not a website. It's not a, where we have all the listed all the sessions for the samosa chai. So you can just go there and see what is coming up next, and make sure you RSVP into your interested sessions as well. So that's it.
Perfect.
So that's it from my end. But if you have any questions, please do ask. We can spend 5 more minutes here.
Yeah. Yeah. Feel free to ask us your questions. We're here hanging out. Um, yeah. This time, no chai and samosa, but maybe I think we should make it a practice to get samosa and chai.
Yeah,
Maybe chai, not samosa.
yeah. No, I have. I just had chai just
I
before the
like
session.
Vivek's. Yeah, I like Vivek's setup now. I mean, like from when we started to where he is right now, like he has like really nice microphones.
Yeah, I
Yeah,
have lightings, I have microphones, and I've written it down there. YAML is the new code. So that's it.
yeah, perfect, perfect. Alrighty,
Okay.
I think we don't have any more questions, so I think we can sign off. Happy Thursday, everyone, and yeah, stay safe, enjoy your time, and come back and meet us during the next time.
Yes. Thank you very much.
Take care. Bye.
Thank you, Nish. Bye bye.
Bye.